So there are some tutorial questions which I've already prepared on differentiation using first principles. Some tutorial questions, so they are already indicated in the voiceover slides that I'm going to be sharing. Make sure you attempt those. Make sure you attempt those tutorial questions. Make sure you attempt those tutorial questions that are available that I'm going to share with you. The tutorial questions I'm going to share with you. Please make sure you attempt those tutorial questions. So then from there now, I think I would proceed and go ahead to talk about another way of differentiating mathematical function, which is differentiation using product rule. So when you differentiate using product rule, how does it work? So that we have a mathematical function which is a product of the name. The reason why we have this name product rule is because it comes from the way the mathematical function is structured. So when you have a mathematical function which is y, and if it's a function of two different mathematical functions that are multiplying each other, if you have y equal to u times v, so u is a mathematical function, v is a mathematical function, different mathematical function. So if you have a mathematical function which is in this format, the way we differentiate it is to use what we call the product rule approach. So how do you differentiate y equal to u times v? Because we want to find the y dx. So if I want to differentiate that, the y dx will give you the formula we usually use using the product rule. We call it u dv dx. It's a formula which you need to know, and you're going to use it to differentiate any mathematical function that is a product of two different mathematical functions that are multiplying each other like this, y equal to u times v. So the formula is the y dx equal to u dv dx plus v du dx. So when you want to differentiate a mathematical function, the formula you use when they are product of two different functions is to use this formula dy dx equal to u dv dx plus v du dx. So that is the formula we use. And we only use this formula when we have a mathematical function which is a product of two different mathematical functions. So let's look at an example for you to understand this. Example 1. Let's try to look at it. Example number 1. So in example number 1, you have this example which is y equal to x raised to the power 4 minus 2x cubed minus 7 into bracket 3x squared minus 5x. So you have this function y equal to x raised to the power 4 minus 2x cubed minus 7, which is multiplying 3x squared minus 5x. So if you can look at this mathematical function, you can see is a product of two different mathematical functions that are multiplying each other. So when you have this kind of mathematical function, you need to use your product rule because you have two mathematical functions. The first mathematical function is x raised to the power 4 minus 2x cubed minus 7. The second mathematical function is 3x squared minus 5x. So these are two different mathematical functions that multiply each other. So when you want to differentiate this, you need to use your product rule, which is dy dx equal to u dv dx plus v du dx. So how do we use this formula? That means for me to use this formula, I need to identify my u in this mathematical function, identify my v in this mathematical function, then try to go and find my dv dx and du dx by differentiating u with respect to x and differentiating v with respect to x. Then when I get my u du dx, v du dx, v dv dx, then I can use this formula to get my dy dx for this mathematical function. So now let's look at it. This is the way we do it is we represent the first mathematical function as our u, then we represent the second mathematical function as our v. So based on this now, it means that my u equal to x raised to the power 4 minus 2x cubed minus 7. Then when I differentiate, because I'm looking for du dx, that means I need to differentiate u with respect to x. So this will give me du dx equal to, when I differentiate x raised to the power 4, don't forget this is a pure mathematical function. By now you must know how to differentiate it. You multiply your 4 the power multiplied by the coefficient of x raised to power 4, which is 1, then x raised to power what? 4, then subtract 1 from it, then minus, what is the power of 2x cubed, which is 3, multiplied by, what is coefficient of x cubed, that is 2, x raised to power what? X raised to power 3 minus 1, then when you differentiate a constant, which is 7, that will give you what? 0. 0. And that means based on that, my du dx will give me, simplify it, that is 4x cubed minus 6x squared, then minus 0, which is this. 4x cubed minus 6x squared. So I need to also do the same thing for v. So I'm going to wipe this off. So let me wipe this off. So I'm wiping this off now. My v, I've represented it as what? 3x squared minus 5x squared. So that means my v will become 3x squared minus 5x. Then dv dx in this case, because I want to get dv dx as shown in the product rule formula. So I need my dv dx. So I need to differentiate v with respect to x. If I do that, that will give me 2 times 3, which is 6, x raised to power, let me be too fast. So that will give me, what is the power in this mathematical function, which is 2. Then I multiply with the coefficient of x squared, which is 3. Then x raised to power 2. Then I subtract 1 from it. Minus, if I differentiate 5x, that is 5x raised to power 1. So that means the power of x, 5x is 1. So that will give me 1 times, what is coefficient of x raised to power 1, which is 5. Then x raised to power 1. Then I subtract 1 from it. So then my dv dx in this case will give me 2 times 3, which is 6, x raised to power 2 minus 1, which is 1, minus 5x raised to power 0. Then anything raised to power 0, like I told you, anything raised to power 0, like I told you, equal to x raised to power 0 will become 1. So that means your dv dx in this case will give you 6x raised to power 1, which is 6x minus 5x raised to power 0 is 1. X raised to power 0 is 1. So that means my dv dx equal to 6x minus 5. And I simplify. So now I know my u, I know my v, I know my du dx, I know my dv dx. Now I can use the product rule formula to get my dy dx, in which the dy dx is u dv dx plus v du dx. So let me quickly do that. If I do that, let me wipe off this. So let me just try to write my du dx. Let me write my du dx somewhere. Maybe I can just leave it like this. So I'm writing this small portion because I need what I've written previously to be able to do this. So don't forget, I'm going to use my product rule formula, which is now dy dx equal to u dv dx, because that is the formula, plus v du dx. So if I do that, I need to substitute. What is my u? My u is x raised to power 4 minus 2x cubed minus 7. Then my dv dx, I've got my dv dx to be 6x minus 5. So that is 6x minus 5. Then my v is, what is my v? My v is 3x squared. 3x squared minus 5x, which I've represented. Then my du dx is 4x cubed minus 6x squared. So that's how you use the formula to go and get your dy dx. Now you need to simplify this mathematical function to arrive at the final answer of your dy dx. So let me quickly simplify. So I'm wiping off the remaining to get my final answer for dy dx. So that means I need to multiply, open the bracket to get my final dy dx. So how do I do that? Dy dx will give me x raised to power 4 times 6x squared. To open the bracket, that will give you 6x raised to power 5, then x raised to power 4 times minus 5, that will give you minus 5x raised to power 4. Then I go to the second one, minus 2x squared, 2x cubed times 6x, that will give me minus 2x cubed times 6x, that will give me minus 12x raised to power 4, because I'm trying to open this bracket for this times this. Then that is minus 2x cubed times minus 5, that will give you minus times minus, which is plus, and that will give you 10x cubed. Then from there, I go to the last one, minus 7 times 6x, that will give you minus 42x. Then minus 7 times minus 5, that will give you plus, minus times minus will become positive, then 7 times 5, that is 35. If you press the calculator. So I've opened these two brackets now. Then from there, I can go and open this bracket. That will be plus 3x squared times 4x raised to power 3. That would give you 3x squared times 4x raised to power 3. That will give you 12x raised to power 5. Then you open this, 3x squared times minus 6x squared. That will give you minus 18x raised to power 4. Then minus 5x times 4x raised to power 3. That will give you minus 20x raised to power 4. So then from there, let's just check it again. This is fine. Then x raised to power 5. Then this is fine. Then this is fine. Perfect. So that's minus 20x raised to power 4. Then minus 5x times minus 6x squared. That is minus times minus, which will become plus. That's 5 times 6, which is 30x raised to power 3. So that is the expression. Then you try to collect the like terms and get the final answer for this to get your dy dx, which is the final solution. So I'm going to wipe this off now. So if you do this now, your dy dx, by collecting the like terms, your dy dx will give you, you have only 6x raised to power 5 plus 12x raised to power 5. You are collecting the like terms. That is the only x raised to power 5 you have there. That is 18x raised to power 5. Then let's look at the x raised to power 4. That is minus 5x raised to power 4 minus 12x raised to power 4. That is minus 17x raised to power 4. Then minus 18x raised to power 4. That is minus 35x raised to power 4. Then minus 20x raised to power 4. Yeah, that is minus 17 minus 18. That is minus 35. Then this will be minus 35x raised to power 4 minus 20x raised to power 4. That will give you minus 55x raised to power 4. Then the next one is I'm collecting the like terms. Let me go to x raised to power 3. That is 10x raised to power 3. Do you have any x raised to power? That is 10x raised to power 3 plus 30x raised to power 3. That will give me plus 40x raised to power 3. Then let me go to x squared. There is no x squared there. And I have x, which is minus 42x. That is minus 42x alone. So that is the only thing I have left, minus 42x. Then I have 35, that is the only number. That will be plus 35. So this is the final solution to the differentiation of that mathematical function, because that is the final solution you can get. And that is the solution to this problem.